Well, hello everybody. Welcome to the review for midterm 4. So we finally made it to the end of the unit. Here is our review. We'll go through and complete this. The first question is use the following A, B, C, or D to answer the questions. And so they're asking us basically how we would prove things. And so to start with this one, if we want to show lines are parallel, we use slope. If we want to show sides are congruent, we're going to use the distance formula. Yeah, and remember the slope formula is y minus y1 over x minus x1, and our distance formula here, remember, is the square root of x minus x1 squared plus y minus y1 squared, so y. And so then that is our formula. To show lines are perpendicular, we would use slope. But remember that for this to happen, we need a slope of one line to multiply by the slope of a second line, and those values to equal -1, so that we end up with, that would be how we determine that they're perpendicular. And then finally, to show that two segments bisect each other, that would be using the midpoint formula. And remember that the midpoint formula is averaging the two x values in an ordered pair and averaging the two y values, and we end up with a ordered pair as a solution for this. So it'll be an x and a y when we do this, okay? So then, as we move along here, it says, on the axis below, plot the points, and to create a rectangle, what would the coordinates of the other vertex be? So if I go ahead and plot these at 0 and 4, I get a point right there. And at 0 and -1, I get a point right there. And then at 7, and -1, I'd get a point right there. So the third point that I would, the point that I would need would be, logically, would be right there. And so that looks like it is 7 over and 4 up. And that would be the point we need. Okay, and so basically all I did was count the distance between these 2 points and say this was changed a little bit, say like this point was moved over 1 or something like that. Say they were moved over a little bit, then you would just count kind of the slope between the lines, and you'd count the slope between the lines of the next one. All right. And so that's kind of how you go about it. It says, then what is the slope of the line perpendicular to the line that contains these 2 points? Well, we're going to find the slope first, and I'm going to do it up here because that's where I got room. Slope of this line would be subtract the y's and divide it by the subtraction of the x's. And so the top becomes 0 and the bottom becomes -4, which basically is a 0 slope, which means the line is horizontal. And so when that happens, the slope that would be perpendicular to this would be an undefined slope. And the undefined slope happens when you have a vertical line, okay? And so that's how we're going to do it. And then otherwise, whatever slope you would, if you would have gotten a different value over here, if you would have, say you would have gotten -1/4, then I would have taken -1/4 times something to get -1, and that would have been a +4. All right, and so just kind of keep that in mind. That goes back to the formula that I used up here for the multiplying them together. So then we're going on to talk about the diagonals and just try to figure out, fill in some blanks here as we go. So the diagonals of a kite are perpendicular. And perpendicular is that symbol or the word perpendicular. Opposite sides are congruent. We could use the word congruent. Congruent. And we can use 2 vertical lines, or we could say parallel. All right. Basically, I'm using symbols to represent, and I would accept the symbols as the answers. I just was trying to show you, make sure we're all okay with this. All the sides of a rhombus are congruent. and the consecutive sides in a rectangle are perpendicular. Okay. And that's the terminology that we're looking for. The diagonal, if the diagonal of the kite, one diagonal is -3, and the slope, what is the slope of the other diagonal? Well, we just said up here in number 7 that the diagonals are perpendicular to one another, so that means -3 times something has to equal -1. And so if I solve this algebra problem and divide by -3, that would mean that that slope that I'm looking for would have to be a positive 1/3. And then finally, in the rhombus math, MA is these two ordered pairs. They're asking us for the length of AT. And so remember that when we're trying to find length of something, we're going to use the distance formula. And so we would say we're going to find the length. And since in a rhombus all the sides are congruent, if I find the length of MA, that's the same as the length of AT. So that's what I'm going to do, is I'm going to subtract my x's from each other, -3 minus -4 squared, and add on 13 minus 9 squared. So I'm going to keep moving down over here because I'm running out of room. So 13 plus 4, that's a 4. 13 plus 4, or -3 plus 4 is 1, so I get 1 squared. And 13 minus 9 is 4 squared. So 4 squared plus 1 squared, it looks like it's going to be 4 squared is 16, 1 squared is 1, so it looks like we're dealing with the square root of 17 is the length of AT. So then we go ahead and they're asking us to, so they gave us this rectangle with the equation of the line, and they said what is the slope of the side AB? And so AB is made up, the side AB in the rectangle is made up of this line, so the slope then is the slope of this line, which is right there, which is 1/4. So that's a 4. I don't know what's going on with my 4s. All right. What is the slope of the side adjacent to this? Well, if it's a rectangle, then the sides are perpendicular, so that would mean I would have to take 1/4 times something to get -1. And basically what that gets me is I would have to multiply by 4 on both sides to get rid of this division. And so then I would be left with x equaling -4, and that is the slope that I'm looking for. And then it says, does the side contain the point 0.5? And how do you know? The answer is yes, because 0.5 is the y-intercept. And remember that that value, if I put in x to be 0, 1/4 times 0, there's my x value of 0 right there. My x value is 0. Do I get 5 out of this? Well, 0 times the -4 is 0, so y comes out to be 5, so that's the ordered pair that we're looking for. All right, we're going to continue on with the review onto the back side of it. They gave us some information about exterior angles being equal to 360, and the sum of the interior angles is equal to n minus 2 times 180, so hopefully that'll help us along the way. So the first question is, what is the sum of the exterior angles? The sum, meaning the total of the exterior angles of the nonagon. Nonagon is 9 sides, but it doesn't matter the number of sides because the sum of all the exterior angles is always going to be 360, so we get 360. And it says, if the measure of one interior angle is 150, what is the measure of one exterior angle? Well, here we go, so I'll just draw you what I'm dealing with here. Here's an interior angle, the shape goes on doing whatever else it does, but if I extend this out and draw the exterior angle, remember that the interior and the exterior angles are supplementary, so that means that these two angles, the exterior angle right there in pink and the interior angle of 150 must add up to be 180, so that leaves me with 30 degrees left over for the exterior angle. Now it says in number 17, how many sides does this polygon have? Well, there's two ways to go about this. Since I know that all the interior angles are 150 and I don't know the sum of all the interior angles, I'm going to have to go to the exterior angles to help me, and that would be 30 degrees. But since I know that all exterior angles are 360 degrees, the number of sides will be 360 divided by 30. Basically, the number of exterior angles is the same as the number of interior angles, which is the same as the number of sides. So if I take 360 and divide it by 30, I get 12, and so this shape that we were dealing with in 17 has 12 sides. So a dodecagon. What is the sum of the interiors of a regular pentagon? Well, here's the formula that we use for a regular pentagon. Pentagon is 5 sides, and so I would say 5 minus 2 times 180, which is the same as saying 3 times 180, and 3 times 180 comes out to be 540. Well, what is the measure of one interior angle of the regular pentagon? Well, if 540 is all of the sides, if I take 540 and divide by the number of sides, that'll give me one interior angle, and the answer that we're looking for is 108 degrees. Moving on down the page. What is the value in the picture? I'm going to fill in the information they gave me. They told me that angle 2 out here is 73 degrees. That angle D is 78 degrees, and C is 61 degrees. So the first question is, what is the measure of angle 1? And the measure of angle 1 is just like what we were just dealing with up here in 17. We have an interior angle of 1, which is what we want to know, and angle 2, which is the exterior angle. So we know that the measure of angle 1 plus the measure of angle 2 will equal 180. So if I fill in what I know, I don't know the measure of angle 1. I know angle 2 is 73 degrees. That must equal 180. And if I subtract the 73 across the equal sign, that gives me the measure of angle 1 must be 107 degrees. And that's what we're looking for. Then they asked me, they're asking, what is the measure of angle B? Well, if this guy is 107 in here, which I just found, now I know this is a four-sided shape, and a four-sided shape has 360 degrees, and if you don't trust me on that, we have a four-sided shape, we subtract 2 times 180, which is the same as 2 times 180, which means 360 degrees is the total of all of those sides. So, since angle A is 107, and angle D is 78, and angle C is 61, we don't know angle B, but that must equal 180 or 360 degrees. Let me fix that, sorry. And I just said it was 360. 360 degrees. And then so if I solve for angle B, do a little algebra here, I add all of those up, combine my like terms, 246 plus angle B is equal to 360 degrees. If I subtract 246 across the equal sign, I get that angle B, that's a 4. The angle B is what's left over, and that's 114 degrees. All right, and that's what we're looking for. All right, and then last but not least down here, we've got a question about, like we've been practicing with our lines and figuring out what shape it is and things like that. So I'm going to graph each one of these lines. The first line I'm going to graph here will be in black. And this line starts, if I put x is 0 in this one, it'll zero out this. That means y is -3. That's my starting point. So at 0, -3, I get a point. And from that point, if I count down 1 and to the right 2, down 1 to the right 2, I will get my line. And that's enough. Let's see, down 1, right 2. So I will now grab a line here and do my best to hit those marks. Alright, I get something that looks like that. The next line that I'm going to do, we'll do it in red. Looks like this. So again, we're starting at -3, but the slope of the line this time, and it's the same thing. If I put 0 in for x, y comes out to be -3, so I don't need to do that part all over again. Since I'm starting at -3 and I count my slope up 2 and to the right 1, up 2 to the right 1, up 2 to the right 1. There you go. I got a pretty good picture of my line. So I will grab a red line here and draw it in. Looks something like that. And this red line probably should be extended down that way. Like that. All right. And then my next line will be a green line. And this guy, if I put 0 in for x, let's move over here. If I put 0, if x is 0, 0, that zeroes out the negative 1/2 x, so that means y is 2. So my new point is up here, and my slope says go down 1, right 2, down 1, right 2, down 1, right 2. All right, so this is my line that I'm dealing with, and it looks like it's intersecting with the other ones, so I'm going to draw in my line. And it should go something like that. And then finally, my last one that I'm going to do is I will graph it in blue. And this guy, again, y-intercept, if I put 0 in for x, I get 2 for y, so I'm dealing with this point. And then it says go up 2 over 1, up 2 over 1, which doesn't really help me out much for this guy, because it looks like I'm going in the wrong direction. But if I was to draw in this blue line and go like that, you can get a pretty good picture of what's happened, what shape we're dealing with, and the shape that we're talking about here looks like it's in here. That is the main focus of the shape that we're dealing with. So to me, that looks like a rectangle. Right, it looks like I see 4 sides up. So it says, other than just looking at the shape you've drawn, what mathematical evidence do you have to verify that this problem is a rectangle? Well, looking at my lines here, the black line and the green line have same slopes. So we have slopes of negative 1/2, two pairs of slopes that are the same. So it's one slope of negative 1/2 and the other slope of 2. So that makes it, by definition, a parallelogram. Right, so I've proven that it's a parallelogram by just looking at it, that I've got 2 slopes of negative 1/2, 2 slopes of 2, parallelogram. Now, so trapezoid and kite are gone from this. I don't have to worry about that. I can now think about how am I going to prove that this is a rectangle. Well, also I know from this that if this is a rectangle, then the slopes of 2 lines should be perpendicular to one another. So at one of the corners here, we'll talk about the blue line and the black line. Well, the slope of the blue line is 2, and the slope of the black line is negative 1/2. And if those guys multiply together to get negative 1, then I have the slope then I know that these lines are perpendicular to each other. So we're going to take 2 times negative 1/2, and we get negative 1. So we know that we have 1 right angle, which means we have 4 right angles, because opposite angles and consecutive angles add up to be 180, and opposite angles are congruent. So we know we have 4 right angles, so that right now we're at either a rectangle or a square. We've ruled out the rhombus because we proved that one of the corners has a right angle in it. And so in order to figure out that this guy is either a square or a rectangle, I need the ordered pairs of each one of these corners. So we're going to put dots on each of these corners. And I'm going to label this point A down here. It doesn't matter where you label them, but I'm going to go A, B, C, and D around that shape. A is because that's the first points we got. And so point A looks like it is at 0, negative 3. B looks like it is at 2 and 1. C is at 0 and 2. And D is at negative 2 and negative 2. All right, so in order to prove that this thing is a rectangle versus a square, if we had 2 sides next to each other that were the same, because we know in a parallelogram opposite sides are congruent, then if I can get 2 sides next to each other that are the same length, then this thing becomes a square. So let's calculate out. So I'm going to find the distance of, say, AD. Let's find the distance of AD and say the distance of AB. Distance of AB. That would, if we can get those to be the same, we have a square, because that would pick up the rhombus portion that the side that we have all four sides the same, which makes it a square. Because a square and a rectangle, we've proven that this thing's a rectangle or a square because of the right angles. So now let's just go with the distance and figure out if the two sides are the same. So let's talk about A and D. I'm going to subtract my x's, 0 minus negative 2. And then I'm going to say negative 3 minus negative 2. That's AD, which then will simplify to 2 squared. Looks like plus negative 1 squared. Well, 2 squared is 4, and negative 1 squared is 1, so I'm looking at the length of AD as the square root of 5. If I want to find the length of AB, I'm going to do the same thing, except for I'm going to use points A and B, so I'm going to say 2 take away 0 squared plus negative 3 minus 1 squared. Well, if I simplify inside the parentheses, I'm left with 2 squared, and on the other side I'm left with negative 4 squared, and so that's a 4. I know it looks like a 9. For some reason my 4s and 9s in this look the same. If I square 2, I get 4. If I square 2, I get 4. And if I square negative 4, I get 16. So I get the square root of 20. And so since these two sides, consecutive sides, are not congruent to one another, then this is a rectangle. We've proven that it's not a square, and so rectangle is the shape it has to be, and that is what we were looking for from the beginning, and that's what we suspected it was. So we just proved what we suspected. All right, so this concludes the video for the review. We can keep practicing this. Come talk to me if you have any questions. Thank you.